Usually when we talk about the security of like a massive institution, say a global bank, the imagery that comes to mind is intensely physical.
Absolutely.
Yeah.
You picture the foot-thick steel vaults, the armed guards at the door, maybe a biometric retina scanner if you've been watching too many movies.
Right, exactly. We are completely conditioned to think of security as this solid, impenetrable physical wall.
It's a very comforting mental model, honestly, because you can visually verify those physical defenses, so naturally you just trust them.
Right. But, okay, imagine finding out that the concrete foundation itself, like the absolute bedrock sitting underneath that steel vault, has this microscopic, totally invisible fracture in it. And not only that, but this fracture has just been sitting there completely unnoticed by the best human inspectors on the entire planet since the foundation was poured like 27 years ago.
Which is terrifying in its own right.
Yeah, but here is the part that really shifts the paradigm today. A machine just found it, a machine running a piece of software that hasn't even been turned on for the public yet.
And that right there, that completely shatters the illusion of the solid wall. I mean, it forces us to basically redefine what a secure foundation actually looks like in the digital age.
It really does. So, welcome to the deep dive. Today, we are unpacking the Tech Reader AI Digest from April 14th, 2026. And our mission for this exploration is to kind of cut through the noise and help you understand how artificial intelligence is just aggressively evolving.
Yeah, we are moving way past AI as a neat technological tool. It's not just something you use to draft an email or generate an image anymore.
Exactly. We are looking at how it has become this foundational systemic pillar of global finance, geopolitics, and honestly, your everyday life.
The overarching theme embedded in all these sources today is that a very specific threshold has been crossed. AI's impact is no longer a theoretical debate.
No, not at all.
And it is certainly no longer localized just to the tech sector. It's a present reality that is actively forcing the hands of Wall Street executives, global governments, and the individual developers building our digital infrastructure.
Right, so let's jump right into the deep end here because our first source reads like a scene straight out of a financial thriller. We're looking at a highly unusual closed-door weekend meeting that just took place at Treasury headquarters in Washington.
Yeah, and this was convened by Federal Reserve Chair Jerome Powell and Treasury Secretary Scott Bessent.
Which, I mean, a weekend meeting called by those two figures.
That immediately signals that we aren't talking about standard regulatory housekeeping. The stakes there are immediate.
Exactly. And the guest list totally confirms that. They summoned the CEOs of America's largest banks. We're talking Citigroup, Morgan Stanley, Bank of America, Wells Fargo, and Goldman Sachs.
Though it's worth noting, Jamie Dimon of JP Morgan was invited but absent.
Right. Interesting little detail there. But the catalyst for pulling the most powerful people in finance into a room on a Saturday was a briefing on a, quote, systemic AI risk.
But the threat wasn't, a foreign cyber attack or anything like that.
No. It was an internal discovery by Anthropic's Claude Mythos preview model. This is an unreleased piece of software.
And the specific technical trigger for this government intervention is what makes this so unprecedented. This unreleased Mythos model autonomously discovered an integer overflow vulnerability in OpenBSD's IPv6 stack.
Okay, I actually have to pause you right there because I see a phrase like integer overflow in an IPv6 stack, and I know a lot of people's eyes, including my own, just start to glaze over.
Fair enough, yeah. Sounds like alphabet soup.
Can we break down what that actually means in plain English and why it threatens a major bank?
Yeah, of course. Let's start with the IPv6 stack. Think of it as the fundamental plumbing of the internet. It's the underlying set of rules that dictates how data packets travel from your computer to, say, a banking server.
Okay, so it's the infrastructure that handles almost all modern web traffic.
Exactly. Now, an integer overflow is a specific type of mathematical error in code. Imagine an old-school car odometer that maxes out at 99,999 miles.
Oh, I know this one. If you drive one more mile, it doesn't go to 100,000. It physically rolls over back to zero.
Right, because there's literally no physical space for that sixth digit.
So how does that apply to the internet plumbing?
Well, in legacy code, a programmer allocates a specific amount of computer memory for a number. If a malicious user purposefully sends a number that is too large for that memory space, the system experiences an overflow.
It rolls over, just like the odometer.
Exactly. And the excess data basically spills into adjacent memory areas. So a sophisticated hacker can use that overflow to inject their own malicious instructions directly into the system's core memory.
Wow. So someone finding an integer overflow in the core plumbing of the internet is basically like a burglar finding a master skeleton key to every bank vault in the world.
That's a perfect analogy, yeah.
But what absolutely blows my mind here is that OpenBSD is globally renowned for its security. Like, this specific flaw has survived rigorous professional security audits since 1999.
Right, back when people were panicking about Y2K.
Yeah, human engineers missed this for almost 3 decades. How does an AI spot a 27-year-old math error that thousands of brilliant human security researchers just glided right past?
It's because human brains naturally abstract information. When a human auditor reads millions of lines of code, they're looking for broad logical patterns and known architectural flaws.
They're looking for the big picture.
Right. They simply cannot hold every single mathematical permutation in their working memory. But a model like Claude Mythos, it doesn't get fatigued. It traces every single mathematical pathway and edge case simultaneously.
Wow.
Yeah, so it found this vulnerability along with thousands of other zero-day flaws across major operating systems, simply by mathematically proving that the code was broken.
Which explains why Canada's banking regulator, the OSFI, concurrently issued their own cybersecurity advisory to Canada's Big Five banks this week, citing these exact Mythos discovery patterns.
And this gets to exactly why this matters to the everyday person's financial security. Modern banking, global markets, the systems holding your retirement accounts, they all run on these massive decades-old code bases.
Right.
The foundational assumption of global cybersecurity was that if code had been audited by enough humans over enough time, it was inherently safe. The autonomous discovery capabilities of Mythos prove that assumption is just totally dead.
So the vulnerability discovery cycle has moved from human speed to machine speed.
Exactly. And it's happening so fast that the Fed and Treasury are trying to figure out how to patch the global financial system before this AI even hits the public market.
Okay, so if unreleased AI software is suddenly powerful enough to trigger emergency meetings at the Treasury, then whoever controls the physical hardware required to build those models essentially controls national security.
That is the crucial connection here. And it brings us right to the most fiercely contested physical choke point on Earth right now, the semiconductor supply chain.
Yeah, according to the Digest, today is the 90-day deadline mandated by Proclamation 11,002, which brings us the Section 232 Phase 2 Semiconductor Tariff Report. This is due to be delivered to President Trump by the U.S. Trade Representative and Commerce Secretary Howard Lutnick. It's the follow-up to the 25% Phase 1 tariffs we saw hit back in January.
And the pre-deadline reporting here outlines a really high-stakes strategy. The U.S. has reportedly reached framework agreements with South Korea, Taiwan, and Japan.
And how do those frameworks operate?
Well, the mechanics of these agreements are designed to reduce the tariff exposure for those countries, but strictly in exchange for legally binding commitments to invest in building semiconductor fabrication plants, commonly called fabs on U.S. soil.
Okay, so it's essentially a tariff offset program for domestic infrastructure.
Exactly. But the report notes that if this Phase 2 is fully triggered without those offsets, it would broaden the categories of semiconductors subject to tariffs at a very significant rate.
Yeah, Commerce Secretary Lutnick was quoted summarizing the strategy as, quote, resilience over revenue.
And you can see the immediate ripple effect in the financial world. The Philadelphia Semiconductor Index, the SOX, closed down 1.2% today.
Driven entirely by the uncertainty of how much these physical bricks are going to cost tomorrow.
Yeah, just look at the sheer volume of capital expenditures hanging in the balance right now.
Yeah.
TSMC's upcoming Q1 earnings confirm $35.7 billion in revenue. That is a massive 35% year-over-year jump.
That's huge.
And then you have Amazon executing a $200 billion capital expenditure plan just for AI infrastructure. CoreWeave is signing tens of billions in server deals with Meta and Anthropic. All of these budgets were modeled assuming a certain baseline cost for these silicon chips.
Okay, let me challenge the logic of this policy approach for a second here, because we have companies like Amazon, Meta, and Anthropic in an absolute death match to win the global AI race.
Oh, absolutely.
And to win, they need millions of these chips. Doesn't heavily taxing the raw materials they rely on directly hurt domestic innovation?
That's a huge question.
Because you are artificially compressing their margins and making it harder for them to build the very systems the government is treating as a national security priority. I mean, the digest even notes that China's DeepSeek V4 model is currently delayed because they're being forced to do a massive kernel rewrite to run on domestic Huawei Ascend 950 PR chips.
Right.
We know hardware struggles are universally painful, so why inflict that pain domestically?
You've zeroed in on the central economic tension of the era right here.
Yeah.
Short-term cost efficiency versus long-term supply chain sovereignty.
Hmm.
From the perspective of the policymakers designing these tariffs, relying on an overseas supply chain for the hardware that dictates your technological future is just an unacceptable vulnerability.
Right.
Yes, the immediate effect is margin compression for Amazon and Meta. It makes building a data center vastly more expensive today. But the counterargument driving the policy is that this temporary financial pain is required to force the construction of a domestic manufacturing base. The strategy assumes that ensuring the U.S. is not physically cut off from AI hardware 10 years from now is worth the cost of slowing down domestic tech giants today.
So it's a calculated gamble. You punish the builders today to force them to pour the concrete in your own backyard for tomorrow. Now, obviously, we are simply analyzing the market mechanics here. We're not endorsing the political strategy either way, but the reality for these tech companies is that the hardware side of their business just became incredibly expensive and unpredictable.
And when the hardware becomes that expensive, the software side of your business has to become perfectly efficient. You can't afford wasted compute, and you certainly can't afford to lose the engineers who are actually building your models.
Which perfectly frames our next segment. Because while governments wrestle over tariffs and fabs, the AI companies are fighting a desperate battle to keep their software developers happy and productive.
Yeah, they really are.
Anthropic just shipped a massive redesign for Claude Code, which they internally called epitaxy. And they really needed a win here because they've been dealing with a massive controversy in the developer community regarding this TTL bug that resulted in a severe token drain.
For context, Claude Code has been a heavily adopted tool, but this token drain issue seriously damaged developer trust.
Let's unpack that TTL bug before we look at the fix, because it sounds incredibly frustrating. What exactly was happening to these developers?
So TTL stands for time to live. In programming, it's a safeguard limit you put on a piece of code to ensure it doesn't run forever. If an autonomous AI agent encounters an error, say a broken file, the TTL is supposed to force it to stop trying after a certain number of attempts.
Okay, makes sense.
But the bug in Claude Code caused that safeguard to fail. So developers would deploy an AI agent to fix a coding issue, go grab a coffee, and the AI would just get stuck in an endless loop, failing and retrying thousands of times a minute.
And because developers pay Anthropic for every single token or interaction the AI makes, an endless loop basically means an endless bill.
Exactly. You could leave your desk for an hour and come back to hundreds of dollars in API charges for absolutely zero productive work. It was literally burning developers' money.
Wow. Well, that totally explains why the epitaxy redesign is so aggressive. They are rolling out this power user co-work style layout. You get multi-repository support, an integrated terminal, file editing, and HTML previews all in one single window.
And to understand why that matters, typically a developer is alt-tabbing constantly between a code editor, a terminal window, a web browser, and an AI chat box. This redesign collapses that fractured workflow into a single cohesive command center.
Right. But the features that really show where Anthropic is heading are coordinator mode, which lets you orchestrate multiple sub-agents simultaneously, and Claude Code routines.
Yes, routines is huge.
Because routines let you schedule automations that run entirely on Anthropic's cloud infrastructure. You don't even need your laptop open or connected to the internet.
And this is a profound conceptual leap. Claude Code is evolving from a tool to a platform. A tool is something you actively type into, wait for a response, and then apply to your work. A platform operates asynchronously.
You just set it and forget it.
Exactly. You give it access to your code base, assign it a goal, and it works on your behalf while you sleep. They are trying to prove they aren't just a smart text box anymore. They are a virtual engineering team. It's a very direct challenge to OpenAI's Codex Super App strategy.
Yeah, and buried at the very bottom of these massive platform updates is something Anthropic quietly labeled the quota efficiency update.
Great.
They never explicitly mention the TTL bug, but suddenly developers on forums like Hacker News are realizing their usage quotas are stretching incredibly far. It really feels like a restaurant that accidentally overcharges a regular customer, and instead of making a public apology about the broken cash register, they just quietly comp the table's appetizers for the next month to smooth things over.
It is the requisite unstated apology. Anthropic knows that if they want developers to trust this new autonomous platform where the AI runs in the background without supervision, they absolutely have to prove that it won't maliciously drain their wallets.
Yeah, that shift from an active tool to an autonomous platform in the background is fascinating. But that shift isn't just happening for high-end software developers, it's moving directly into the consumer space too, straight into the device sitting in your pocket.
And this brings us to the pocket frontier. We are seeing a massive technical push to take these massive frontier-class models and literally squeeze them onto consumer hardware.
Which is creating a very sharp geopolitical divide.
Oh, absolutely.
The numbers Google is putting up right now illustrate this perfectly. Their AI Edge Gallery app just cracked the top 10 on the Google Play Store. And the driver of this virality is that Google has managed to ship Gemma for Sci-Fi, a highly capable AI model, and get it to run 100% offline on your phone.
Which is what?
Yeah. It requires no internet connection, no API keys, and no cloud processing. It's running locally on older iPhones and Android 12 devices.
The engineering required to achieve that is staggering. They are relying on a technique called sub-4-bit quantization. They've managed to maintain 98% of the model's accuracy while crushing the file size down to fit into just 6 gigabytes of RAM.
Okay, how does that actually work? Because neural networks are massive. They're usually housed in billion-dollar data centers. How do you shrink a brain that size to fit on a 3-year-old smartphone without giving the AI severe amnesia?
So to understand quantization, you have to look at how an AI's intelligence is stored. A neural network is made up of billions of connections called weights. Historically, these weights are stored as highly precise floating point numbers. Think of a number with dozens of decimal places.
Okay.
It is incredibly exact, but it takes up a massive amount of physical memory to store.
So millions of incredibly long numbers just clogging up the system?
Right. Sub-4-bit quantization essentially takes a meat cleaver to those decimals. It rounds those massive numbers down into a much smaller, far simpler 4-bit format.
What doesn't that break it?
Well, in early AI development, yeah. If you aggressively rounded off the weights, the model suffered catastrophic brain damage. It would forget its training and just produce gibberish.
Right.
The breakthrough Google is utilizing is in the algorithm that determines exactly how to round the numbers. It mathematically identifies which specific connections are vital for the AI's logical pathways to survive, and which can be safely rounded off without breaking the system.
So it's basically identifying the load-bearing walls of the AI's intelligence, keeping those super precise, and aggressively stripping down everything else.
Exactly.
And the result is that Google can offer features like agent skills, an audio scribe for offline meeting transcription, and a thinking mode, all entirely contained on your local hardware.
Which represents a massive leap forward for consumer privacy. Your prompts, your private health data, your voice recordings, they are processed on your phone and never sent to a corporate server.
But this hyper-localized, intensely private Western approach sits in stark contrast to what we are seeing globally. Because our digest also highlights China's Z.AI, formerly Zipu AI, which just listed on the Hong Kong Stock Exchange.
Yeah, and they just released GLM 5.1.
Right, which is an open source model that directly rivals the capabilities of Claude Opus 4.5. But their strategy is really fascinating. They open source the model globally under an MIT license, completely free to use. Simultaneously, they are raising their global API prices by 10 to 17%, while keeping their domestic Chinese API prices heavily subsidized by the government. Why give away your most advanced technology for free, but hike the prices to actually interact with it?
Because it is a highly calculated geopolitical maneuver. You have to remember that Z.AI currently sits on the U.S. Commerce Department's entity list.
Which is effectively a trade blacklist restricting their access to Western technology and capital.
Exactly. They cannot compete by simply buying massive amounts of U.S. hardware. So they use this two-pronged strategy. First, by open sourcing a frontier model like GLM 5.1 for free, they capture the mindshare of developers all over the world, particularly in emerging markets.
They become the default operating system for developers who just can't afford Western models.
Right. And second, the heavy domestic subsidies ensure that Chinese startups can build on this ecosystem for pennies, fostering intense local innovation. They use the free open-source model as a loss leader to undercut Western dominance while shifting the actual cost onto global API users who rely on their infrastructure.
It's an incredibly complex global chessboard.
Mhm.
We have Western companies optimizing for private, compressed, offline consumer compute, while state-subsidized entities use open-source strategies to navigate international blacklists and export their technical standards.
It really is.
And speaking of complex chessboards, it's a quick final note from the digest. Jury selection for the Musk versus OpenAI trial begins in just 13 days, which is going to add yet another layer of legal friction to this entire landscape.
The landscape is just shifting beneath our feet daily. The technical, the geopolitical, and the financial spheres are completely intertwined now.
What an incredible journey we've taken today. I mean, we started by examining the terrifying reality of a 27-year-old internet plumbing failure autonomously discovered by unreleased software.
Right.
We looked at the multi-billion-dollar stakes of semiconductor tariffs and the strategy of trading short-term profits for long-term supply chain sovereignty. We saw how developers are navigating endless token drain bugs as AI evolves from a tool into a background platform. And finally, we unpacked how massive data center intelligence is being mathematically crushed to fit into our pockets.
It is a massive amount of information to process, but it highlights that whether you are managing an investment portfolio, writing code for a startup, or simply using a transcription app on your phone, these invisible technical forces are actively dictating the boundaries of your digital and physical world.
I think that's the perfect encapsulation of why we do these deep dives. But before we go, I want to leave you with one final thought to ponder.
We spent a significant amount of time today dissecting how Claude Mythos mathematically proved the existence of deep vulnerabilities in legacy code that was written, audited, and maintained by human beings over the last 3 decades.
Right.
But we are rapidly approaching an inflection point.
Yeah.
What happens when these advanced AIs are no longer just auditing human code, but writing the entirety of our digital infrastructure themselves? When these systems become so incredibly dense, intricate, and optimized by machine logic that human engineers can no longer read or comprehend how they actually work, who audits the code then?
Wow. That is genuinely unsettling. If the best human minds couldn't spot a vulnerability in a simple mathematical foundation we built ourselves, how are we ever going to spot the invisible fractures in a digital world built entirely by machines? Thank you so much for joining us as we unpack the digest today. Keep questioning the systems around you, keep exploring, and we will see you next time.